It's easy to assume we all experience the world in, well, roughly the same way.
Mm-hmm.
But have you ever stopped to consider just how differently our senses might interpret the same input?
It's a great question.
Think about it. The same melody could stir completely different emotions, right? The same artwork, different feelings. Okay, let's really dig into this, because today we're venturing into the fascinating realm of unique sensory experiences.
Yeah.
Those incredible variations in human perception that extend far beyond the usual five senses we all learn about.
And what's truly remarkable, and what the source material you've provided really underscores, especially that understanding synesthesia and other unique sensory experiences piece, is just the sheer adaptability and the diverse wiring of the human brain.
Right.
It really challenges our assumptions about a uniform sensory reality,
Right.
opens up this whole world of individual perception.
Absolutely. And that's our mission for this deep dive, to unpack these intriguing phenomena, synesthesia, ASMR, misophonia, aphantasia, and hyperphantasia, in a way that's both illuminating and hopefully thoroughly engaging for you.
Yeah, consider it a shortcut.
Consider this your express lane to understanding a really cutting-edge area of research into how we all experience the world.
And if we zoom out for just a second, this whole exploration really speaks to the concept of neurodiversity, doesn't it? This understanding that these differences in brain wiring are, natural variations, each with its own set of characteristics rather than being deviations from some norm.
Right, not necessarily problems to be fixed.
Exactly. And as the source notes, things like neuroimaging tech and just the internet really have played a huge role in validating these experiences.
Yeah.
And helping people find communities.
Okay, here's where it gets really interesting. It struck me that countless individuals might be navigating the world with these unique sensory experiences without ever realizing their perception is, in fact, quite distinct.
Totally possible. They might just assume everyone experiences things that way.
Which sets the stage for some potential aha moments for you listening as we delve into these fascinating differences. So let's plunge in, starting with something truly mind-bending. Synesthesia, where senses kind of team up in unexpected ways.
Synesthesia is definitely a captivating place to start. The source gives a clear definition. It's a genuine neurological phenomenon.
Okay.
Where stimulating one sensory or cognitive pathway, like seeing a letter involuntarily, triggers experiences in another, typically unrelated pathway, like seeing a color.
Involuntarily, that's key.
Yes, it's not imagination, and importantly, it's not seen as a disorder. It's more a fundamental difference in how the brain processes information. And these synesthetic experiences, they're remarkably consistent for each person throughout their life.
Okay, so if someone consistently perceives the letter G as, say, green, that's not just a random thought popping into their head.
Precisely. That's it. And the source introduces a helpful distinction here. Projectors versus associators.
Okay, what's the difference?
Well, a projector might actually see the color green, overlaid on the G itself, almost as if it's out there in the physical world. An associator, though, experiences the green more internally. It's a strong mental association, a feeling in their mind's eye, perhaps.
Got it. So one is almost seeing it externally, the other is more of an internal connection. Now, why is studying synesthesia so valuable for scientists? What does it tell us about, typical brain function?
That's a really important point. By studying synesthesia, as the source explains, we get valuable insights into how different sensory regions normally specialize and, crucially, how they communicate. Theories like cross-activation, this idea of increased or unusual neural connections between sensory areas, that's a big one. Or maybe incomplete synaptic pruning during brain development.
Pruning, like trimming back connections.
Exactly. Maybe that didn't happen as much in synesthetes. And there's also the semantic vacuum hypothesis, which is pretty interesting. It suggests synesthesia might be like an amplified version of how we all initially learned to link abstract concepts like letters with sensory experiences early on.
So it's almost like a learning aid that's stuck around.
Could be. Fundamentally, synesthesia shows us our senses aren't as separate as we might think. It hints at a more interconnected brain architecture that maybe we all possess to some degree.
So the brain just took a slightly different developmental path, maybe leaving these extrasensory links.
Sure.
The source mentions some common forms. Let's start with grapheme-color. What's that one about?
Right. Grapheme-color synesthesia, it's one of the most studied forms. This is where letters or numbers, these written symbols we call graphemes.
Like A, B, C, 1, 2, 3.
Exactly. They involuntarily and consistently trigger the sensation of specific colors, so that G being green is a perfect example.
Okay.
And what's so interesting is, well, the specific color for each letter is unique to the person. Your green G might be my red G.
If I had it, yeah.
Right. But those pairings stay remarkably stable for that person over their whole life.
That's fascinating. What makes the brain link, say, G with green for one person and red for another? Is it random?
It doesn't seem totally random. The source points to a mix of factors. The visual shape of the letter itself, its sound, the foam it's placed in the sequence, like the alphabet order.
Ordinality, right?
Ordinality, yeah. How often the letter is used, even personal memories, maybe those colored alphabet blocks you had as a kid.
Okay. That makes sense.
And interestingly, these influences can even vary depending on the writing system, like English versus Japanese hiragana. It's remarkable how consistently those pairings form, though.
And for the synesthetes themselves,
Yeah.
these colors just feel normal. Part of the letter. The source mentioned Patricia Lynn Duffy.
Yes, she described them as just a matter of fact for her. Often people only realize later in life that not everyone sees letters that way. It really highlights that paradox. Strong consistency within one person, but huge variety between people. It suggests, maybe some underlying neurological predisposition allows these links, but then individual experiences shape the specific connections.
Okay, so letters and numbers can have colors. What about the sounds? That was chromesthesia, I think.
Exactly. Chromesthesia. Here, sounds, music, voices, even just everyday noises like a car horn, they involuntarily evoke experiences of color.
Wow.
And sometimes shapes, even a sense of movement, too. These visuals are called photisms, like the specific color burst the sound creates.
Photisms, okay.
And they happen in addition to actually hearing the sound. And just like grapheme color, the specific color associations are very individual, but consistent for that person.
Is there a pattern? Like, does a high note tend to be a lighter color, low note darker?
That's a common factor, yeah. The source notes many chromesthetes report higher pitches linking to lighter or brighter colors, lower pitches to darker ones. But other things matter too. The timbre of the sound, the volume, even the emotion in someone's voice can influence the colors. Apparently, the composer Franz Liszt reported experiencing music in color.
Huh. Amazing.
And again, you get that projector-associator difference. Some see the colors projected externally, like an aura around the sound source. Others experience them more internally.
Wow, just picturing music as like a personal light show playing in your mind, or even right there in the room. Okay, the next one sounded quite different. Auditory tactile synesthesia. Sounds making you physically feel things.
Yeah, it's a rarer form. Affects less than 1% of people, apparently. Here, sounds trigger actual tactile sensations on the body.
Like what?
Things like tingling, pressure, changes in temperature, sometimes even sensations of pain. Hearing a specific word might consistently make you feel a touch on your arm.
Whoa.
Or listening to, say, heavy metal music could bring on a feeling of pins and needles for someone. It's striking how direct that sound-to-touch link can be.
That sounds incredibly intense.
Yeah.
Are there certain types of sounds that tend to trigger specific feelings?
The source suggests maybe some general patterns. Lower frequency sounds might be more often linked to deeper feelings like vibration or pressure,
Okay.
while higher pitched sounds could lead to tingling or tickling. And interestingly, studying people who've acquired this type of synesthesia, maybe after a brain injury like a thalamic lesion.
Acquired it. You can develop it later.
Apparently so, though it can be different from the developmental kind. But studying those cases gives clues about the brain's amazing capacity for, like, cross-modal remapping, how it can rewire itself.
The brain's adaptability is just incredible. Okay, next up. Lexical gustatory synesthesia. Words. Tasting like things. That sounds almost like science fiction.
It is pretty extraordinary and particularly rare. Here, spoken or written words, sometimes even just the thought of a word triggers specific taste or even smell sensations.
Not just sweet or sour, though.
No, often incredibly complex, involving different textures, temperatures, almost like actually eating the food. The source gives that amazing example, the word society, consistently tasting like fried onions for one person.
Fried onions. That is so specific.
And
it's always the same taste for the same word, year after year.
that's what the source emphasizes, the remarkable consistency over time. And research suggests these tastes might even link back to foods the person had strong experiences with in childhood.
Fascinating.
There's even an online tool, the multi-sense test, that researchers use to diagnose this. It rigorously checks how consistent those word flavor pairs are.
Absolutely incredible stuff. And the source briefly touched on a couple of others, spatial sequence and mirror touch.
Yes, spatial sequence synesthesia is where sequences, numbers, months, days of the week are perceived as having specific locations in space, like they form a kind of mental map or shape around the person.
Okay, like a timeline in 3D space.
Sort of, yeah. And mirror touch synesthesia is really intriguing. That's feeling a touch on your own body when you simply watch someone else being touched.
Whoa.
This form has been linked to higher levels of empathy. It might involve the mirror neuron system, the brain cells that fire both when we act and when we see someone else act. Maybe here, that mirroring extends to actually feeling the observed touch.
All of this just keeps expanding my understanding of how differently we can all experience the world. So how does this actually happen in the brain? What's the neurological basis for synesthesia?
Well, the source digs into several key theories. The cross-activation theory is a leading one, proposed by researchers like V.S. Ramachandran and Edward Hubbard.
Right.
It suggests synesthesia comes from increased neural connections or just more crosstalk between brain regions that are usually more separate. For instance, the brain area for processing letter shapes is right next door to an area for processing color.
Proximity matters.
Exactly. The idea is, in synesthetes, there might just be more wiring, more connections between those adjacent areas.
But the brain's wiring diagram ended up slightly different, letting signals kind of leak across.
That's a good way to put it. And that idea of incomplete synaptic pruning fits here too. Normally, as we grow up, the brain refines its connections, gets rid of some excess ones from early life. The hypothesis is, maybe in synesthetes, that pruning process wasn't quite as thorough, leaving more of these cross-sensory connections intact.
Makes sense.
There's also the disinhibited feedback theory. That suggests there's less suppression of signals traveling back from higher-level brain areas to the primary sensory areas.
Those signals that are meant to stay in one lane are kind of spilling over into another.
That's a decent visualization, yeah. And crucially, neuroimaging studies, fMRI, DTI, they've actually shown real, tangible differences in the white and gray matter structures of synesthetes' brains.
Oh, wow. So it's physically observable.
Yes. For example, they've found increased connectivity near the fusiform gyrus in people with projector grapheme-color synesthesia, and heightened activity in a specific temporal lobe area in chromesthesia. What's really compelling is that brain imaging can even show activity in the expected sensory area, like the V4 color area lighting up, when a synesthete just looks at a black and white letter G that they perceive as green.
Okay, that's strong evidence.
It provides really strong neurological validation for their subjective experiences. It's definitely not all in their head in that dismissive sense.
Right. What about genetics? Does synesthesia tend to run in families?
Yes, there's a clear familial link. The source mentions about 40% of synesthetes have a close relative, like a parent or sibling, who also has synesthesia.
40%, that's quite high.
It strongly suggests a genetic influence, but it's probably complex, likely multiple genes involved, maybe creating a general susceptibility rather than inheriting a specific type of synesthesia.
So you might inherit the tendency, but whether you get grapheme-color or sound to touch might depend on other factors.
Exactly. And those earlier ideas about it being linked to the X chromosome, they've largely been disproven by newer studies showing a pretty even split between genders.
Interesting. So probably a combo of genes making the brain more prone to these cross-links, and maybe early learning experiences shaping the specifics, like which color gets paired with G.
That fits really well with the developmental theories. That semantic vacuum hypothesis suggests synesthesia might act as a cognitive scaffold when kids are first learning abstract stuff like letters or numbers. The synesthetic link could be like a built-in memory aid. And the neonatal synesthesia theory proposes that maybe all babies start out with more interconnected senses, and synesthesia just happens when those connections aren't pruned back as much in some people.
Fascinating.
And it's worth mentioning again that synesthesia can sometimes be acquired later from brain damage, sensory loss, even certain drugs, though these acquired forms can differ from the developmental kind.
This is all incredibly fascinating. Okay, so how does actually living with synesthesia impact people day to day? Are there benefits, challenges?
For most synesthetes, the source says it's generally neutral or even pleasant, just part of how they experience the world. But there can be certain cognitive advantages.
Like what?
Enhanced memory is a big one. Those synesthetic associations can act as powerful mnemonics, ways to remember things.
It makes sense.
Some synesthetes also show improved sensory processing within their linked sense, like better color discrimination for grapheme color types. And these unique links can be cognitive anchors, helping detect or retain information.
So it raises that evolutionary question, doesn't it? If there are benefits, could that be why it stuck around in the population?
It's an intriguing possibility, yeah. Maybe it offers some subtle cognitive edge.
What about creativity? I feel like I've heard synesthesia is more common among artists and musicians.
There's definitely a higher reported rate among creative individuals. Famous examples like Nabokov, Kandinsky, David Hockney, they all reported synesthetic experiences influencing their work.
Right.
But the source points out the link might be complex. It's not necessarily that synesthesia directly causes creativity. The connections are often arbitrary, unlike metaphors, which usually have some conceptual logic.
So maybe it does make you better at writing metaphors, but it gives you a richer, more diverse sensory palette to draw from for your art.
That's a good way to think about it, yeah. It could inform their creative expression in unique ways.
What about the downsides? Any practical challenges in daily life?
While mostly neutral or positive, some challenges can pop up. Sensory overload in really stimulating environments could be an issue for some. Incongruent stimuli, like seeing a letter printed in the wrong color according to their synesthesia, can be jarring or distracting.
I can imagine.
And occasionally just social misunderstandings. Trying to explain these very personal sensory worlds to people who don't experience them can be tricky.
Yeah, that makes total sense. Like having this extra layer of info others just aren't tuned into.
So how do researchers actually identify synesthesia? Is it like formally diagnosed?
The source clarifies it's generally not seen as a disorder, so it's not in the main diagnostic manuals like the DSM or ICD.
Okay.
Instead, researchers look for key characteristics. Okay. The experiences have to be involuntary, automatic, consistent over time, often felt in a specific location, spatially extended, memorable, and sometimes have an emotional quality.
Consistency seems really key. It's crucial for verification in research. They often use test-retest procedures, asking about associations weeks or months apart to see if they stay the same. There are also online tools, like the Synesthesia Battery, people can use to explore their own potential experiences.
And it feels like public awareness of synesthesia is growing, which must be a good thing.
Absolutely. It's fueled by research, media attention. Current estimates suggest at least 4% of people might have some form.
4%, that's not insignificant.
Not at all. And public figures or artists talking openly about it has definitely helped increase understanding.
So what are the big remaining questions for researchers? What are they digging into now?
The source lists several key areas, the precise neurogenetic mechanisms, understanding the developmental trajectory better, the full range of cognitive and perceptual effects and their neural bases, distinguishing between subtypes like projector versus associator more clearly, its potential links to other conditions like autism, and just developing better models for specific forms like grapheme-color. Researchers like Julia Simner, Ramachandran, David Eagleman, Janina Neufeld, they're really pushing the field forward.
Okay, synesthesia is clearly super rich and fascinating. But the title of our source mentioned other unique sensory experiences. Let's move on now, maybe starting with something that's become huge online. ASMR, the science of tingles, as some call it.
Right, autonomous sensory meridian response, ASMR. It's definitely intriguing. The source defines it by that pleasant, often described as sort of electrostatic-like tingling sensation.
The tingles.
It usually starts on the scalp, back of the neck, and can spread down the spine, maybe into the limbs.
And it feels good, relaxing.
Yeah, often accompanied by deep relaxation, euphoria, calmness, just an uplifted mood. Some researchers think ASMR might be like a modern digital version of ancient social bonding behaviors, triggering similar calming pathways.
Interesting. What usually triggers it? I know whispering is a big one.
Whispering, yeah, soft speaking, tapping, scratching sounds, crinkling, even certain mouth sounds, those are common auditory triggers.
Okay.
Visually, it could be slow, deliberate movements, watching someone do meticulous tasks, or those role-play scenarios simulating personal care or attention.
Right, like virtual haircuts or something.
Exactly. Apparently, low-pitched audio tends to be pretty reliable, and effective triggers often last a few minutes and feel, realistic and focused.
It's so interesting how these specific, sometimes mundane triggers cause such a profound response in some people. And it really seemed to explode online, maybe around 2010.
Yeah, the rise of ASMR is undeniably tied to platforms like YouTube. But that social grooming hypothesis the source mentions is fascinating.
Tell me more about that.
It suggests ASMR might tap into really old, evolutionarily conserved mechanisms for comfort, bonding, social connection, similar to grooming in other primates.
So it's like scratching an ancient social itch, but digitally.
That's one way to think about it. A modern way to fulfill that innate need for gentle, focused social interaction, maybe?
Huh. So what's actually going on in the brain during ASMR?
Research is still kind of new, but moving fast. fMRI studies show activation in brain areas involved in attention, social cognition, reward processing, sensory integration. Places like the anterior, cingulate gyrus, movement-related areas too.
Okay.
There are a few hypotheses floating around. One is about the default mode network, which is active when we're resting or introspective. Another points to the mirror neuron system fostering empathy and connection. And it's very likely engaging neurochemicals like endorphins, oxytocin, dopamine, things linked to pleasure, relaxation, social bonding.
So multiple systems seem to be involved. And there are actual physical changes too, right? Like heart rate going down.
Exactly. Studies have measured a significant drop in heart rate during ASMR, a clear sign of relaxation, but also, interestingly, increased skin conductance, which usually signals arousal.
Hey, relaxation and arousal, how does that work?
It's this paradoxical reaction, as the source calls it. That simultaneous mix might be key to what makes ASMR feel unique and appealing. There are also changes in brain waves, consistent with focus or meditation.
It definitely is a unique feeling. What are the main benefits people report? Relaxation, sleep.
Those are the big ones. Stress and anxiety reduction, better mood, improved sleep. Some people anecdotally report relief from chronic pain, too. And enhanced focus, getting into a flow state. Plus, that feeling of simulated personal attention can create a sense of social connection for some.
Sounds like a pretty accessible form of digital comfort for those who experience it. But not everyone does, right?
No, highly individual. Estimates suggest maybe only around 20% of people consistently experience ASMR.
20%, okay.
And even among responders, triggers and intensity vary a lot. Personality traits seem to play a role, too. And importantly, for some people, especially those with misophonia or other sensory sensitivities, ASMR triggers can actually be irritating or distressing.
The opposite effect.
Right. And sadly, some report developing tingle immunity, like desensitization over time.
Like you build up a tolerance. Interesting. So online awareness is huge, but the science is still playing catch up.
Precisely. The term itself is pretty recent,
Yeah.
but online awareness is massive. Prevalence around 20%. Researchers like Julia Porio, Emma Barrett are doing great work. Future research will likely look at long-term effects, individual differences, refining the neurobiology, therapeutic potential.
Yeah.
We're already seeing cool findings linking it to personality profiles and those measurable physiological changes like heart rate.
Okay, so moving from pleasant tingles
Yeah.
to something that sounds, well, the opposite. Misophonia, hatred of sound. That's intense.
It is. Misophonia means a significantly decreased tolerance to very specific sounds, trigger sounds.
Okay.
Exposure causes intense negative emotions, anger, rage, disgust, anxiety, panic.
Wow, rage.
Yeah, and it's usually paired with strong physical reactions, muscle tension, faster heart rate, sweating, that whole fight or flight response.
And the triggers are often just everyday noises, like someone
Yeah.
chewing.
Exactly. Eating sounds, chewing, sleeping, swallowing are super common triggers. Breathing sounds too. Repetitive noises like pen clicking, keyboard tapping.
Oh, man.
For some, even just seeing the action that makes the sound can be a trigger that's sometimes called misokinesia.
Okay.
The key is the reactions are involuntary. People feel a total loss of control. The core issue seems to be the brain assigning abnormal importance or salience to these specific sounds, leading to this hyperactivation of emotional and defense systems. The anterior insular cortex involved in detecting salient stuff seems really key here.
So it's way beyond just being annoyed. It's a visceral, overwhelming reaction. What's happening in the brain to cause that?
Neuroimaging shows hyperactivity in that anterior insular cortex, AIC, when people with misophonia hear their triggers. There also seem to be abnormal connectivity patterns between the AIC and other regions involved in emotion processing and regulation. One idea is the hypermirroring hypothesis. Since many triggers involve mouth movements, maybe the sound causes an excessive, unpleasant mirroring of those movements in the listener's motor system.
Ah, interesting.
But that doesn't explain non-oral triggers, so it's not the whole story. There might be structural brain differences too, maybe in myelination, and definitely a heightened autonomic nervous system response.
And like synesthesia, does misophonia run in families? Is there a genetic link?
Evidence strongly suggests yes. It does seem to run in families, indicating heritability. A genome-wide study even found a specific genetic spot potentially linked to rage from chewing sounds.
Wow, that's specific.
Yeah, and there's significant genetic overlap with things like anxiety disorders, PTSD, depression, and traits like neuroticism and irritability.
So maybe a genetic predisposition makes some brains extra sensitive to these sounds, leading to that intense negative reaction. How does this actually impact daily life? It sounds incredibly disruptive.
It can be profoundly impairing across work, school, social life, everywhere. The intense reactions often lead to avoidance behaviors, like avoiding family meals.
Exactly. Or public transport, social events, anywhere they might encounter triggers. This can cause huge social isolation, strained relationships, misunderstandings. People just don't get it.
Yeah.
Mental health issues like anxiety, depression, OCD traits often co-occur. People develop coping strategies, earplugs, noise-canceling headphones, white noise, just leaving situations. Mimicking the trigger sound sometimes helps some people too.
Huh.
What's really tough is the low public awareness compared to how common and severe it might be. People can suffer for years without knowing what it is or getting help.
It really highlights the need for formal recognition for research and treatment. How is it diagnosed now if it's not in the main manuals?
Right, it's not formally in the DSM or ICD yet, which is a barrier. But expert consensus criteria are emerging. They focus on specific triggers, often oral nasal, the intense negative reaction, the person recognizing it's excessive, the avoidance or distress causing real impairment, and ruling out other conditions.
There are also assessment tools now, questionnaires like the MAI or AMISO-S to help measure symptoms.
And awareness is growing, maybe slowly.
Yeah, the term was coined back in 2001. Awareness is increasing, especially online and through media, but still pretty low overall. Organizations like the International Misophonia Foundation are doing vital work, raising awareness and supporting research.
What about treatments? Is there a cure? What helps?
No known cure currently, so therapy focuses on management, improving quality of life. CBT techniques are often adapted, challenging negative thoughts, maybe gradual exposure therapy.
Exposure therapy. That sounds tough.
It has to be done very carefully, yeah. Sound therapies, like using masking sounds, can help some people. Relaxation techniques, mindfulness, emotion regulation skills. Addressing co-occurring conditions is important too, and there's emerging research on neurostimulation, like TMS.
It sounds like a really challenging condition needing much more attention. Okay, shifting gears again. Let's talk about aphantasia, mind's eye blindness. This is basically not being able to voluntarily form mental images.
That's the essence of it, yeah. People with aphantasia report an inability to consciously conjure visual images in their mind's eye. When they try to picture something, it's blank.
Blank. Like nothing.
For many, yes, but it's important to know it's a spectrum. Total aphantasia is that complete lack, but there's also hypophantasia, where imagery is maybe dim, vague, fleeting.
Yeah.
And what's wild is many people live for years, maybe their whole lives, not realizing they're different. They just assume phrases like, picture this, are purely metaphorical.
That's mind-boggling. To think some people literally cannot picture their own parent's face when they try. Is it considered a disorder?
Generally, no. Not a disorder or medical condition, more a neurological characteristic, a natural variation in how the brain works.
Okay.
And while they can't voluntarily visualize, some might get involuntary flashes of imagery or still have visual dreams, and it might not just be visual. Some report similar lack of auditory imagery, like hearing music in their head. The very existence of aphantasia really challenges old assumptions that mental imagery is fundamental to all thinking and memory. It shows just how diverse brain strategies for processing information can be.
So how does the brain of someone with aphantasia differ? What's going on neurologically?
Neuroimaging shows reduced activity in the visual cortex back of the brain and the hippocampus, crucial for memory when they try to visualize or recall memories.
Okay, less activity there.
Yeah, and differences in functional connectivity, how brain regions talk to each other, often reduced communication between frontal networks for attention, control, and visual networks. Also, potentially altered connectivity between the hippocampus and visual cortex during memory retrieval.
Interesting.
Some studies even show, paradoxically, increased activation in visual areas during memory tasks, maybe a compensatory strategy, or unconscious visual processing happening. It's complex. It's not just a dark visual cortex, but differences in how the whole network interacts.
So the brain is incredibly adaptable, finding other ways to remember and think. How does aphantasia affect memory, learning, creativity then?
Memory-wise, people often report less vivid autobiographical memories. They remember the facts, but don't relive events visually. Recalling faces or navigating using mental maps can be harder.
So they rely more on.
Verbal descriptions, context, logic, maybe recognizing people by voice or how they move, they tend to favor verbal or logical memory strategies, not visual mnemonics.
Okay.
But interestingly, spatial imagery, mentally rotating objects, understanding spatial layouts can often still be surprisingly strong, even without visual object imagery.
Huh.
And critically, aphantasia does not prevent creativity. Many successful artists, writers, innovators report having it. People like Ed Catmull, a Pixar co-founder.
Wow, really?
Yeah. Their creative process might rely more on conceptual development, iteration, external references, focusing on emotion or narrative instead of vivid internal pictures. It shows the brain's plasticity, alternative pathways.
That's really important to know. What about emotions? Does it affect emotional experience?
Maybe. Emotions tied to vivid visual memories might feel different, less intensely relived. Some speculate it could even offer some protection against visual trauma, like PTSD flashbacks. Grief might be experienced differently, too.
How is aphantasia identified? Are there specific tests?
Mostly it's self-report questionnaires right now. The VVIQ Vividness of Visual Imagery questionnaire is the main one. Low scores suggest aphantasia or hypophantasia.
Huh.
Researchers are working on more objective measures using binocular rivalry tasks, drawing, physiological responses, but self-report is still key. And again, it's not classified as a disorder.
And awareness really seems to have exploded since the term was coined fairly recently, in 2015.
Absolutely. Professor Adam Zeman formally named it. Media picked it up. Online communities like the Aphantasia Network formed. It led to a huge surge in awareness and research interest.
What are the prevalence estimates?
Around 1–4% for total aphantasia, maybe up to 10–15% reporting low or dim imagery. So not super rare.
And the research field is booming now.
Exactly. People like Zierman, Joel Pearson, research groups in Bonn, Plymouth, the Aphantasia Network, they're making big strides. Recent findings link it to that hippocampus visual cortex connectivity affecting memory detail, realizing it's often multisensory, exploring links with autism traits, which seems variable, possibility of unconscious visual stuff.
Lots happening.
Yeah. Future work will refine the definition, develop better objective tools, look at neural underpinnings, impact on learning, cognition, emotion, social aspects. The spectrum nature and multisensory aspect are key focus areas.
Okay, so aphantasia is the lack of vivid mental imagery. What about the absolute opposite end of that spectrum? Hyperphantasia.
Yes, hyperphantasia. That's characterized by exceptionally vivid, intense, often photorealistic mental imagery.
Like seeing it as clearly as real life.
That's how I'm going to describe it, yeah. As vivid as real seeing, and it often extends across all senses. They can hear, smell, taste, feel things vividly in their minds. They can visualize text clearly, imagine complex scenes, recall past events with intense sensory detail. A very immersive internal world. It's more than just a good imagination. It's a different quality of intensity and fidelity.
So what's thought to be going on in their brains?
Likely involves a widespread network, prefrontal, parietal, temporal, visual areas. Some specific findings are interesting. Maybe an inverse relationship between the size of the early visual cortex, V1, V2, smaller V1 linked to stronger imagery, but coupled with a larger frontal cortex.
Huh. Smaller visual cortex. That seems counterintuitive.
It does. Maybe lower baseline activity or excitability in V1 allows for stronger internally generated imagery. And studies show significantly stronger functional connectivity between the prefrontal cortex and the visual cortex, like a supercharged imagery network.
So their mental imagery network is like a superhighway. What are the benefits of having such a vivid inner world? Sounds amazing.
Often linked to enhanced memory, especially detailed autobiographical memory, that mental time travel, maybe faster decision-making through vivid simulation. Increased creativity is often reported pursuing creative fields, visualizing complex designs or stories easily. Also linked to the personality trait of openness to experience, curious, imaginative, emotionally responsive.
Okay.
And it can enhance problem solving via simulation and make experiences like reading or listening to music incredibly immersive.
Sounds almost entirely positive.
Yeah.
But the source mentioned a double-edged sword. Are there potential downsides to such an intense imagination?
Yes. That vividness can magnify risks too. There might be links to increased susceptibility to mood disorders, anxiety, OCD, depression, bipolar, maybe due to more intense visual rumination or vivid negative flash forwards.
Oh, okay.
Possibly increased risk for PTSD with more intrusive, potent, traumatic memories. It might even aggravate some psychotic symptoms like hallucinations in schizophrenia or Parkinson's. Some researchers even wonder if it's a trait marker for schizophrenia risk via that smaller V1 finding. Practically, some might struggle distinguishing vivid fantasy from reality or feel overwhelmed by the intensity of their inner world. Challenges with daydreaming, concentration, need to manage distressing thoughts or vivid nightmares.
Right.
And interestingly, higher rates of synesthesia are also seen, suggesting maybe shared mechanisms like increased neural connectivity or excitability.
So a balance, like with many things. How is hyperphantasia identified? Mostly self-report again.
Primarily, yes. Very high scores on questionnaires like the VVIQ, often near the maximum score. Newer tools like the Imagery Extremes checklist are emerging too. And like aphantasia, it's seen as a cognitive variation, not a disorder.
And awareness is growing alongside aphantasia research.
Exactly. Still relatively new in popular terms, but gaining traction. Prevalence estimates are maybe around 3–6% of the population.
What are the research directions now for hyperphantasia?
Researchers like Zeman and Craig Reeder are looking into it. Many imagery spectrum studies now include hyperphantasia. Recent work focuses on those neurobiological correlates, like the prefrontal visual connectivity, links to openness, memory, creativity. Future work will look at precise neural genetic basis, relationship with creativity memory types, mechanisms of mental health impacts, better objective measures, potential subtypes, how it manifests across all senses.
It's truly fascinating how these different points on the sensory spectrum and the blending in synesthesia just highlight the incredible diversity of human experience. We can start to see how they might relate, can't we? Common threads, contrasts.
Absolutely. You can kind of think of them along a continuum of sensory gating and integration. Like aphantasia might be very stringent gating of internal visual info, hyperphantasia very permeable. Synesthesia is atypical integration. Misophonia may be an overreactive negative response to certain gated sounds, ASMR a positive response to other gated stimuli. Underlying mechanisms of sensory gating thalamus, cortical inhibition excitation, and cross-modal integration could be a unifying framework.
And the source material had that helpful table summarizing key features, definition, senses involved, experience type, triggers, prevalence, neural correlates, impact, disorder status. Seeing them side by side really helps compare.
Exactly, and specific comparisons are interesting. Synesthesia versus ASMR both involve cross-modal links or triggers, but the experience and likely neurobiology are quite different.
Right.
ASMR versus Misophonia can share triggers, like human sounds, and both cause strong physiological emotional reactions, but the valence is opposite. Pleasure relaxation versus intense negativity. Parasympathetic versus sympathetic activation.
All are opposites in feeling.
Right. Aphantasia versus hyperphantasia, direct opposites on imagery vividness, contrasting effects on memory, creativity, problem-solving, different neural patterns.
Yeah.
Synesthesia versus aphantasia, hyperphantasia. Synesthesia adds a perception. Hyperphantasia is about vividness of perception. Synesthesia often links to bioimagery, but can occur in aphantasics, usually associator type, which challenges theory saying you need strong imagery for all synesthesia.
It really drives home that having more or different sensory processing isn't automatically good or bad. The impact depends so much on the specifics, the person's coping, the environment. And the source brought up neurodiversity and sensory processing sensitivity, SPS.
Yes. These phenomena, especially synesthesia, aphantasia, hyperphantasia, ASMR sensitivity, fit well under the neurodiversity umbrella. Natural variations, not deficits.
Okay. I know SPS.
Sensory processing sensitivity. It's a trait maybe 15–30% of people have it characterized by deeper processing of sensory info, heightened awareness of subtleties, linked to more activation and awareness, empathy, emotion-brain regions.
How does that connect?
You see potential overlaps. Misophonia is clearly extreme negative sensitivity. ASMR responders might be higher in openness, responsive to subtle cues. Hyperphantasics often report keen emotions, vivid sensory imagination. Aphantasia, interestingly, sometimes links to lower general sensory sensitivity. SPS itself has strengths, empathy, creativity, depth, and challenges, like overstimulation or anxiety in the wrong environment.
And it seems these different experiences can sometimes co-occur in the same person.
Yes, that's a really interesting area. Notable co-occurrence between synesthesia and ASMR, over half of synesthetes might have ASMR. ASMR responders 4x more likely to have synesthesia. Hints at shared mechanisms, maybe heightened sensory awareness.
Wow.
Possible link between synesthesia and misophonia, maybe a negative sound emotion synesthesia. Both involve idiosyncratic triggers, automatic responses.
Okay.
ASMR and misophonia relationship is complex, can share triggers but opposite outcomes. Some ASMR responders report more misophonia symptoms, suggesting maybe an underlying sensitivity to sound patterns. Aphantasia doesn't prevent synesthesia, usually associator. Hyperphantasia links to higher rates of synesthesia. Aphantasia and autism traits have a variable link. Aphantasia sometimes links to lower sensory sensitivity overall. Familial tendencies across some suggest shared genetic or neurodevelopmental roots leading to different styles. Research in one area informs others. Integrating subjective reports with science is key.
These personal accounts shared in the source material really add so much context and depth.
Yeah.
Hearing directly from people experiencing these things just brings it all to life.
Absolutely. Those examples are invaluable. Patricia Lynn Duffy, realizing her colored letters were different, Feynman's colored equations, they show how ingrained grapheme-color synesthesia is.
Yeah.
James Wannerton tasting message as sausage vivid, lexical gustatory, descriptions of ASMR tingles, relaxation, people using it for calm or sleep. Then the stark contrast. Intense anger, panic from chewing sounds and misophonia, feeling trapped, isolated.
Yeah, the impact sounds huge.
And the aphantasia accounts. Blake Ross, unable to picture his dad's face, Ed Catmull failing to picture a sphere, others describing the black screen, but having active inner monologues, strong factual memory, reframing it.
Assuming picture this was just a metaphor.
Exactly. And then hyperphantasia, experiencing novels like movies, mentally navigating cities, the cinema in her head being a creative superpower, but also avoiding horror films because they're too real, vivid nightmares.
It's fascinating hearing those common threads, too. That moment of realizing they're different, the journey to understand, the relief of finding a name, a community, especially for aphantasia, synesthesia, misophonia.
Definitely. And it underscores the brain's adaptability, especially aphantasics developing compensatory strategies, alternative strengths like verbal memory, logic. It challenges our assumptions about what a rich cognitive life means.
Right.
Aphantasia isn't necessarily a deficit. Hyperphantasia has challenges. Synesthetes often treasure their perceptions. Well-being isn't just about having a typical sensory profile. It's about adaptation, understanding, acceptance.
It all comes back to just the stunning diversity of human sensory experience these phenomena reveal.
Yeah.
It really makes you think about how subjective our individual realities are.
Precisely. And it's so important to keep saying these are largely neurological variations, not pathologies, though misophonia clearly can be significantly impairing. Each one, synesthesia's blended senses, ASMR's tingles, misophonia's distress, aphantasia's lack of imagery, hyperphantasia's vividness, offers a unique window into how we perceive and interact with the world.
And that shift towards a neurodiversity framework is so crucial for fostering understanding, accommodation, support. Awareness is key for individuals and scientists.
Absolutely. Future research across all these areas, synesthesia genetics, ASMR therapy potential, misophonia treatments, aphantasia, hypophantasia neural basis, and impacts will keep deepening our knowledge. Understanding these atypical connections ultimately gives us fundamental insights into how these complex systems work in everyone.
So as we wrap up this deep dive, it really does prompt you, the listener, to maybe consider your own sensory world, any unique aspects you hadn't thought about, maybe a subtle touch of something we discussed. Embracing this incredible sensory diversity, it really does lead to a more comprehensive, nuanced, and ultimately, I think, a more compassionate understanding of what it means to be human.